When we go to the Listeners tab, the first thing we see is again the time filter. In this case, it allows us to select the time range we want to consider. However, the information it shows here is slightly different from what we saw in the main tab. As we'll recall, listeners are the entry point into Onum, so in this tab, we see the number of events that have entered the platform during the selected time range, along with some basic statistics like the average number of events per second, the maximum and minimum values recorded, and also the amount of data in bytes that has entered or exited the platform, again showing the average, maximum and minimum. This gives us a clear and immediate overview to determine whether the data entering our platform or system aligns with what we would expect. We can check here if the traffic patterns are stable, if they match our system's demand for data, or if they align with the expected traffic volume for the monitored time of day. Regarding the listeners we have created, we can view them in card format, which is shown here, or in table format. In table format, the data is more extensive, though possibly less visual. In both formats, the same information is displayed, so it comes down to personal preference. In either view, we can filter by listener type, helping us find specific listeners we've created. For instance, we may have Kafka, NetFlow, or PubSub listeners. In card view, we can see the same information, for example syslog and HTTP formats. To create a new listener, we'll just click the New Listener button and select the type we're interested in. For example, if we choose syslog, we proceed to configure it. Most listeners are configured in a very similar way. They all include a metadata section, where we must give the listener a name and optionally provide a description and a set of tags to organize the listeners we create. We must also select the port it will listen on. For syslog, for example, we also need to select whether the protocol will be TCP or UDP, and how events will be separated. If necessary, we can configure TLS settings based on our requirements. If we create an HTTP listener, we configure it with a name, optional description and tags. Then we choose the port, any required TLS configuration, the authentication type supported by our server depending on how it's set up, and the HTTP method used for requests. We also define the path to which requests will be made, how to extract fields based on how the data arrives, and how to separate events. We can specify the behavior related to headers, select which headers to use, define the format for exporting headers, set a maximum message size, the status code to return, the content type, and even customize the response message. Overall, we can see that configuring a listener is quite simple.